Hey everybody, welcome back to chemistry. If I can increase the slide. So here in this problem it says identify the approximate bond angles in each molecule. And if you look from left to right, I'm hoping you can sort of see that there are three different molecules there. One is called glycine, another in the center is called acetonitrile, and then there's a third one to the right which is called nitrous acid. Those Lewis structures for each of these three molecules are correct. So what you have to do for each of these molecules is you have to find the correct bond angles that are indicated in each molecule. So in the first molecule to the left, you have to find 3 bond angles. The middle molecule, you'll have to find 2 bond angles, and then the one on the right, you have to find 2 bond angles. Okay, if I can reduce the slide. Okay. So what I'm going to do is I'm going to do the first molecule, and then I'm going to let you guys do the rest. So the good news is this. With all of these molecules, we have already figured out a correct Lewis structure. And so we can go on to the next step, is we can figure out the number of electron groups on a central atom. And then step 3, we can figure out the electron geometry around the central atom. And then finally, we should be able to figure out the angles between the bonds. Okay, so here in this molecule, inevitably what they want is the angle between the bond leaving oxygen going to hydrogen and the bond leaving oxygen going to carbon. So you have to identify what the central atom here is. And so let me circle that. Let me get a different pen here. So this is the central atom here that we have to consider. Okay. So you have to figure out the number of electron groups that this central atom has. And so you might recall that the number of electron groups is equal to the number of bonding groups the central atom has plus the number of lone pairs. So one thing you can see is that this central oxygen atom has 2 lone pairs, and each of these single bonds is a bonding group, so it has 2 bonding groups. So 2 lone pairs plus 2 bonding groups, and so we have a total of 4 electron groups around that oxygen there. So let me just indicate that this is 4 electron groups. So my hope at this time is that you understand whenever you have 4 electron groups around a central atom, you can expect a tetrahedral 3-dimensional geometry. So let me just indicate that here. This is tetrahedral. So let me draw a quick picture of what this might look like. I'll try to do it in 3-dimensional space here. So it might look like this. We have oxygen here in the center, and then we have hydrogen, say, going up. And then here we have the rest of the molecule. We have a bond going to carbon here. Maybe there's a double bond here to another oxygen. And then there's more of the molecule. And so I'm going to write an R here to indicate that there's more to the molecule. And let me put in lone pairs around that oxygen there. Okay. This oxygen has lone pairs. Let's imagine what it might look like. So here you might have a lone pair heading out toward you. And here you might have a lone pair going into the screen. And so I'm hoping that this 3-dimensional picture, as best as I could draw it, highlights that this is a 3-dimensional entity and that the angles between everything here, whether it be the angle between, say, this hydrogen and the lone pair, and this lone pair and this lone pair, the lone pair and the carbon here, and the carbon and the hydrogen here, these angles are not going to be 90 degrees. They're going to be around 109.5. And they're not going to be exactly that, but they're going to be close to that. So the answer for the angle here between this bond going to hydrogen, this bond going to carbon is about 109.5. So let's go ahead and do the analysis for the other 2 really quickly. So here we're trying to find the angle between the double bond leaving carbon and going to oxygen and the single bond leaving carbon and going to the other carbon. So this is the central atom here, which is the carbon. And so first thing we need to do is figure out how many electron groups this carbon has. And so each single bond is considered a bonding group. The double bond is considered 1 bonding group. Carbon has no lone pair. So it looks like we have a total of 3 electron groups. So 3 electron groups. And so I'm hoping you know that when you have 3 electron groups around a central atom, the electron geometry is trigonal planar. So this is going to be trigonal planar. So really quickly, what this might look like is imagine these atoms that we're considering are in the same plane. So I'm trying to draw a plane here. And so we have carbon here, and then we have double bonded to oxygen. And then leaving this carbon, maybe we have going to another carbon and the rest of the molecule. And then here, the other side of the carbon has an oxygen, and that is going to the rest of the molecule. And what I'm kind of hoping you know at this point, when you have trigonal planar geometry, because these three electron groups are in the same plane, when they get as far away from each other as they possibly can, the angles here are going to be about 120 degrees. So the answer for this one should be about 120 degrees. Okay, we have one more. So what we will do is we will consider here this central atom here, the nitrogen, because that determines the bond angle between the nitrogen and the carbon and the nitrogen and the hydrogen. So what I'm hoping you can see at this point is that that nitrogen has 4 electron groups. And the reason why it has 4 electron groups is because it has one lone pair, and then each of these single bonds is considered to be a bonding group. So it has a total of 4 electron groups. So this is 4 electron groups. This is tetrahedral. Now I could draw a picture of this. I'm not going to. It'll look similar to that. And so you might expect that all the angles here between the bonds and the lone pairs, they're going to be about 109.5. So this angle here between the carbon and the nitrogen, hydrogen is going to be about 109.5. So I'll let you figure out the rest. Thank you for listening. We'll see you next time.